All right. Good morning, everybody. We're going to be starting a unit on stoichiometry this morning. Stoichiometry comes from a Greek word, stoichion, which I think means counting. And what it is, it's a way to mathematically manipulate chemical quantities of things. If we're getting in the lab and I'm giving you directions, I might tell you, okay, well, use like however many grams of a substance, or however many milliliters of a substance, or a certain number of drops of a substance, or fill a test tube about halfway. But if we're wanting to get really, really precise and keep track of how many molecules of something we are working with, or how many grams of something is going to be produced in a reaction, then we need to get a little more technical, a little more specific. Before we get into how stoichiometry works, I just want to do a very quick refresher. If you remember way back at the start of the year, we did dimensional analysis. We just kind of dipped our toes into it, played around with it. And the whole idea there is it's a way of doing conversions by taking whatever you're given in a problem, putting it over 1, turn it into a fraction, and then you're going to use conversion factors for however many steps you need to convert in order to change it into what you need. And you set it up in such a way to where whatever unit you start off with that's in the top is always going to be in the bottom in the next step. And what that allows you to do is it allows you to cancel units until you're only left with the unit you need. So if I've got whatever my red unit is, and I know how to turn reds into greens, I need to get to blues, but I don't know how to turn reds into blues. But I can turn reds into greens by setting it up like this. And I know that maybe for every 1 red, there's 2 greens or something. Okay? Well then, I know that for every 3 greens, I can make 5 blues. And so in my next step, I can set it up where, since I had green on top here, I can put green on the bottom there. That way when they're all multiplied out, I can cancel green units. And what I'm left with are these blue units that I'm trying to get to. Okay? And then the big rule for all of this is once you've got the whole thing set up, whatever's on the numerator side, all the ones on top, you're going to multiply them all together. Whatever's in the denominators, the ones that are on the bottom, we're going to divide by each of those. Okay? And that's just stuff we did earlier this year. I know it's been a while. We're going to get lots of practice. Don't worry. So if that's a little bit dusty, then we'll have everybody up and working really, really well by the time we get to the end of 6 weeks. Now it's necessary when we look at stoichiometry, we need to be mindful of 2 important concepts. Okay, I'm going to go ahead and skip. First important concept is the concept of molar mass, or formula mass. Okay? And I know that we just, I think for one day back in October, talked about what a mole was. So I just want to remind you, a mole is just a really big number. It happens to be a really big number that we can use to count really tiny things like atoms or molecules. And the way that we get that is we take a look at the chemical formula. Like right here, we've got the chemical formula C6H12O6. Anybody know what that is off the top of your head? That is exactly glucose, exactly. Simple sugar. So if I wanted to find out how much 1 mole of glucose was in grams, what I do is I would go to the periodic table, and I'm going to look for each of the elements. And the elements that are in there are carbon, hydrogen, oxygen. I'm going to look up the mass of each one of those on the periodic table. And when I look, carbon has a mass of 12.011. Hydrogen has a mass of 1.008. Oxygen has a mass of 15.999. Okay. Now, is it okay to round those to the closest whole number? Sometimes yes, sometimes no. Keep in mind, the more that you round something, the less accurate it becomes. So typically, I don't want you rounding until you get to the very last step of something. Okay? So what I'll do is I'll take those masses, like this 12.011 for carbon. I see how many carbons are in the molecule. There's 6, so I'm going to take that, and I'm going to multiply it times 6. Can somebody give me 12.011 times 6? 72.206? Somebody confirm?
Yes.
Okay. All right. Now we're going to do the same thing for hydrogen. Hydrogen has a mass of 1.008 on the periodic table, but there's 12 hydrogens in the molecule. So what's 1.008 times 12? 12.096. Cool. All right. And then oxygen has a mass of 15.999 on the periodic table. There's 6 of them in the molecule. So what's that times 6? 95.994. Okay. Now, to get the total mass of 1 mole of this stuff, I'm going to take those 3 and I'm going to add them up. So would somebody, actually several somebodies, go ahead and add those 3 for us. 180.156. Somebody confirm? Okay, cool. 180.155 or 156. There we're talking like 1,000th of a gram, so we don't have to be quite that picky. Now, if I wanted at this point to go ahead and round it, it's awfully close to 180, okay? Or maybe 180.1. So if I want to get 1 mole of glucose, I get my balance out. I get out a tray that I can pour stuff into or set stuff on. And I'm going to measure out 180 grams of glucose. And I know that 180 grams of glucose is about 1 mole of glucose molecules. Okay? Now, let's talk about what I can do with that. Before we do, when you're looking at something like aluminum carbonate here. Now, aluminum carbonate, since that's an ionic compound, we don't actually consider this to be a molecule. It's given a different name. It's called a formula unit. But if you just want to call it a molecule, who cares? Okay? It's a particle. It's a little piece. Okay? The name is not the most important part here. When I'm given something like Al2CO33, keep in mind what that means is that I've got 2 atoms of aluminum and I've got 3 of these polyatomic chunks, 3 of these carbonate ions. So out of this, how many total aluminums do I have? Okay. How many total carbons do I have? 3. Okay. How many total oxygens do I have? I have 9. So, if I wanted to find what the mole mass of aluminum carbonate was, I'd need to look up the mass of aluminum. Somebody who's got a periodic table handy. What's the mass of aluminum in here?
26.98.
Okay, so 26.98 what?
1.
26.981. Okay. What's the mass of carbon? I know that one. That's 12.011. And oxygen is 15.999. Okay. So I would take 2 times 26.981. That's going to be, I'm just going to estimate, just to kind of save some time here. That's going to be awfully close to 54. 3 times 12.011 is going to be awfully close to 36. And 16 times 9, okay, so 10 times 16 would be 160, so 144. 144-ish. Then I add those up. 36 plus 54. It's going to make 90 plus 144. So 234. Okay, so right around 234 grams is going to equal 1 mole of this stuff. The formula mass is the number of grams that are in 1 mole of my substance. And it can be 1 mole of atoms, like you see here with carbon. 12.011 grams of carbon is going to equal 1 mole of carbon atoms. It can be in terms of molecules or formula units. So here I've got an oxygen molecule, O2. That'd be 15.999 times 2, because there's 2 of them, which would be about 31.998 grams, or awfully close to 32 grams. Okay, so if I could measure out in a balloon 32 grams of oxygen, I would have 1 mole of O2. 1 mole of O2 molecules. But that's what we refer to when we refer to formula mass or molar mass or just mole mass. They all mean the same thing. Sometimes you hear it referred to as molecular weight or molar weight. That's not accurate, but it kind of means the same thing. Okay? They're all interchangeable. So getting back to conversions, which is really what this whole thing is about. If you're looking for a conversion factor, jump again, to get between grams of a substance and moles of that same substance, or moles of a substance and converting it to grams of that same substance, then you are going to be either multiplying it or dividing it by the formula mass, by the mole mass. Let's say that I had 100 grams of silver, and I wanted to know how many moles that was. Well, I'd go to my periodic table, I'd find silver, and I'd see that it's 107.8682. And so that tells me, since I've only got 100 grams, do I even have a whole mole of silver? No, I've got a little bit less. So if I took 100 divided by, what did I say? 107.86, let's call it divided by 108. If I divided this by 108, what is 100 divided by 108? 0.926. That would tell me I've got 0.926 moles. And moles is, you just write M-O-L instead of writing M-O-L-E-S. It's not much of an abbreviation, but you know, it's a thing. Or let's say that I had 20 moles of, let's say lithium chloride. If I wanted to change it from moles into grams, I'm going to multiply by the mole mass, and so lithium's got a mass of 6.941, chlorine's got a mass of 35.453, so that's about 35.5 plus about 7, that's about 42.5. So if I take 20 times 42.5, somebody hit that for me. Yep. Okay, about 850-ish. Okay, sounds about right. So it's going to be about 850, not 85. It's going to be about 850 grams of lithium chloride. Okay. Now the nice thing about dimensional analysis, again, is you don't have to memorize, okay, now do I divide by this? Or do I multiply by this? I don't remember. All you have to do is whatever you're given in the first step goes on the bottom in the second step. Okay? So that'll tell you if you have to divide or multiply. Now, remember when we talk about 1 mole, 1 mole is 6.02 times 10 to the 23rd. And that's whether you're talking about a mole of atoms, that's whether you're talking about a mole of chicken wings, okay, a mole of bananas, a mole of whatever. It's just a number. But 1 mole is always going to equal 6 times 10 to the 23rd, or 602 sectillion. And it's not going to be terribly often that you have to convert stuff into numbers of atoms or numbers of molecules or numbers of formula units, numbers of particles, period. But it's handy to keep that in mind, okay? Because sometimes you will get asked. And so just like what we had with our molar mass, if you're converting something from moles to molecules or atoms or particles or whatever, then you're either going to be, if you're going from moles to particles, you multiply by 6 times 10 to the 23rd. If you're going from particles back to moles, you divide by 6 times 10 to the 23rd. I have 2 moles of paper clips, and I want to know how many paper clips that is. I just take 2 times 6.02 times 10 to the 23rd. And so I would have something like 1.2 times 10 to the 24th paper clips. So if I take this entire thing and put it together, don't write this down yet, just hear me out. Then I could start at any point along this chain, grams or moles or molecules, and I could use either my formula mass to convert it, or I could use the mole number to convert it. If I am given grams of something and I want to know how many molecules that is, well, first of all, I divide it by the mole mass. Then I'm going to multiply it by the mole number. If I'm given a number of molecules and I want to know how many grams that would be, I'm going to divide it by the mole number to turn it into moles. Then I'm going to multiply it by the mole mass to turn it into grams. Okay? You can start in the middle and go either way. That's just like a road map. You guys ever cross a river? Anybody like ever do any hiking and you come to a river and it's not real wide and you're like, I think I can get across that, but maybe not in one jump, so what do you look for? You look for rocks. You look for something sticking up out of the water so you can like hop to one, whoa, and then like, throw your back out, and then hop to another one and, make your way across. These are like stones in the river, and this right here is how you hop from one to the other. That's all this is. It says the molar mass of nitrogen dioxide is 46.01 grams per mole. It's very nice then to go ahead and total that up for us. So how many moles of nitrogen dioxide are present in 114.95 grams? Well, identify what are we given in this problem. What is the quantity they start us with? They're giving us grams, okay? You see that right here? This right here, we are given grams of NO2. Are you cool with that? What do they want us to find? They want us to find moles of NO2, okay? Now, we're going to do this a couple ways. One, we're going to use our little road map here. If we're given grams, it means we're starting right here. Where do we need to hop to? We need to hop this way. So what are we going to do to get there? We're going to divide by the molar mass. So we're just going to go 114.95 divided by 46.01, which that's our mole mass. Couple will calculate that for us and tell us what you get. 2.498. All right. Very nice that they gave us multiple choice for that. That's not always going to be the case. That's going to be 2.498 moles of NO2. Now, if you didn't have the roadmap, how would I set this up using dimensional analysis? It's going to be easy. I start with what I'm given. I'm given grams of NO2, so I'm going to start off with 114.95 grams NO2. Remember, you want to use the units. Put it over 1. Okay. And the next step, I need a conversion unit. I know that 1 mole is equal to 46.01 grams. So since grams are on the top right here, 46.01 grams of NO2 goes down here, and 1 mole of NO2 goes right here. So I cancel my units, grams of NO2 divided by grams of NO2. I'm left with moles of NO2, which is what I want. So then I just multiply everything on top, divide by everything on bottom. So again, it's 114.95 divided by 46.01. You see, that way I don't have to remember all this mess. Okay? I just remember whatever I'm given up here goes on the bottom of the next step. Easy peasy. Questions? Let's look at another one. Let's see. All right. So the molar mass of carbon tetrachloride is 152.81 grams per mole. How many grams of CCl4 do you have 5 moles? What do they give me here? They give me how many moles?
5.
They give me 5 moles. That's my given, right? What do they want me to find? They want me to find grams. Okay? So according to my roadmap, where am I starting from? Okay, I'm starting here at moles, and I'm trying to get to grams. So this time, what do I do to get there? I'm going to multiply by the mole mass. Okay? If I didn't have the roadmap, if I wanted to set this up using dimensional analysis, then I'd start off with 5 moles of CCl4. I'll put it over 1. My next step, I know that 1 mole of CCl4 is 152.81, so I'm going to put the 1 mole of CCl4 down here. And I'm going to put 153.81 grams of CCl4 up here. Moles cancels moles. Since they're both on top, it's 5 times 153, so 56. We got 750-ish or more, right? Oh gosh. So is it going to be closer to C or closer to D? Closer to C, right? And then you could always use your calculator just to be safe. But yeah. And that's how we solve that. Again, this is a really good place for questions. This is all, show me scale of 1 to 5 fingers. How are you feeling about this? Be honest. Oh, we got some 5s, some 4s. Oh, I love that. 3, that is fine. Okay. We're doing good. Let me see if there's a couple other ones here. All right. You know what? This is not one that we can use our roadmap to solve. What's the polar meal mass of ethyl alcohol, C2H5OH? How do I figure this out? Great. Find the masses on the periodic table. Okay. So, since this is multiple choice, we can do a little bit of rounding, since none of our answers are real super close together. So I've got 2 carbons, okay? And there's 2 of them, so that's going to be 2 times its mass, which is 12.011, so I can just do 2 times 12, 24. I've got 5 hydrogens. That's 5 times awfully close to 1. That's 5. I've got 1 oxygen. That's 1 times awfully close to 16. And then I've got, oh, there's another hydrogen right there, so that's actually 6 hydrogens, I'm sorry. 6 times 1, that's 6. So 24 plus 6 plus 16, 24 plus 6 is 30, plus 16, that's about 46. So what's my best answer? I'm liking D, honestly, but that's close enough with the 45 there that you might want to actually go back and like do the full decimals. I'm 99% sure the answer is D. Okay. But I'm in a rush, so I'm not going to bother checking it right now. And really for today, that's the main thing. You can use dimensional analysis or a roadmap like this to do all kinds of conversions between grams, moles, and number of particles. All you need to know is how to find the formula mass, and that's just some simple addition.